So today I'm going to talk to you about wrapping REST with GraphQL. It's probably a thing that you deal with. Who here uses a REST API on a day-to-day basis? Raise your hands. There's some people who don't raise their hands. That's kind of strange to me, but that's OK. REST, I'm going to kind of skip over the definition of some of these things. REST is going to be your high level, like you have a resource URL and you have an ID afterwards. There's like there's different specs and schemas around it. Not everyone follows it fully, but generally this is the thing that you get whenever you ask someone for an API. They're going to give you a REST API. Hopefully that's GraphQL at some point, but that's not today. You're going to have to deal with REST, I guarantee you. A little bit about myself. My name's John. I work, as Evans mentioned, at Coursera. It's an education company. Check it out. I'm sure you can figure it out. I work on the front-end infrastructure team, where we deal a lot with the workflows, processes, tools, libraries, all the things that our front-end developers do and use to build great products at Coursera. And at Coursera, we've been using GraphQL for about a year and a half now. For a little bit more context, a lot of Coursera, actually all of Coursera is powered by REST APIs. And we wanted to, a year and a half ago, try and figure out what was the best way to get from REST to GraphQL. So a lot of the things that you're going to be hearing here are strategies, things that we've learned in that process of getting to GraphQL, as well as reflections, because that happened a year and a half ago. So what are the things that we've learned since then? What are the strategies that I might use today if I had to redo the same thing over again? And hopefully that you can use these strategies as you are trying to migrate to GraphQL, hopefully at your company or organization or your project or whatever. So who is this talk for? This talk is for people who know what GraphQL is, people who obviously know what REST is, people who want to get to GraphQL and trying to figure out how are they going to deal with all of this incumbent REST things. And again, I'm going to skip over the basics of GraphQL here. This should be for people who are kind of like in the process of doing these sorts of things. So at a high level, I'm going to cover a few different sections. The first is strategies for actually proving that you need and or should have GraphQL. This is really important. If you can't convince anyone at your organization that you need GraphQL or use GraphQL, the rest of it is slightly a moot point. It's going to be hard to do if you don't have any buy-in. The second is schemifying your REST APIs. If you've seen any REST API recently, there is no documentation built in. It can kind of just return whatever it thinks that it should return. It might not be well documented, and if it's documented, it might be in like a markdown document or something like that. You're going to need schemas. The third is being a good tenant. So if you are trying to build GraphQL on top of these REST services, someone else owns those REST services. They're going to complain if you do weird things, and if they complain, then maybe you don't get to use GraphQL. So finding ways to make sure that you are a good tenant when using GraphQL, as well as the last piece, pulling it all together and creating and hosting that GraphQL layer that you can use for all of your client development needs. So first, let's talk about proving out GraphQL. Let's actually figure out if GraphQL is the thing that you need. And this is an important decision to make for any technology. Whether it's React or GraphQL or whatever it is, always make sure that it actually solves a problem at your company, not just some shiny tool. Here's one way to do it. One is that you don't even need to build a GraphQL server to figure out if GraphQL is the solution for some of your needs. You can actually build all of this in the browser. It's all JavaScript. You can import it into your Webpack thing. This is a link to a great blog post on GraphQL.org about how to actually structure your first GraphQL schema in your browser. And all it's going to do is just going to delegate REST requests, or if you just mock some JSON there. And that way you can see, is GraphQL the thing that makes sense for my product and and the things that I'm writing. Other ways to do this, or you might be able to prototype this using services like Amazon AppSync and GraphQL. Those are systems that have basically hosted GraphQL servers. So again, trying out the whole system, figuring out all the technical decisions first before actually diving into building your own GraphQL server. Because building your own GraphQL server comes with a lot of other problems that you might not want to deal with just yet. Here's the second big thing that you're going to need. You're going to need to schemify your REST APIs. Again, this is important because GraphQL itself is built on schemas. You need to have some sort of catalog of what your REST API is going to be able to provide in order to create the GraphQL API into that. So the sort of high-level decisions that we had to decide on to figure out how we were going to generate our GraphQL schema came in 3 flavors. One is, should we write these by hand? Should we auto-generate these? Or maybe should we do a mix of both? And this is important, again, because you need a schema for your GraphQL server. So I'm going to go through some of the pros and cons for each of those different options that you had. So the first is manually writing your GraphQL schema. This sounds great. This is going to be in all of your tutorials. In your Apollo Launchpad, you're going to be writing schema definition language. That's your SDL. And it's pretty simple. You can see here, it's a little washed out, but you can see it's just, here's a type pet. It has a name. It needs a string. It's going to return you a string. They're pretty straightforward to write, and that's great. I know there's a lot of schemas out there that can be a little bit strange. GraphQL is really, really easy to read. The other thing that's beneficial here when you're creating your GraphQL schema, your big GraphQL schema, when you're manually doing it, you have a lot of flexibility. So if this field was actually supposed to be a number instead of an ID, or maybe this number or was supposed to be a string or something like that, you can make that change in the GraphQL layer and not have to deal with what the actual underlying type was. And it allows you to really easily compose your different REST resources. So as you translate more REST things into GraphQL, you'll be able to start linking them into a graph. The cons from writing a manual GraphQL schema, this is going to get out of date really quickly. You have one schema over here, which is your GraphQL schema, and you have your REST API over here, and they have no relation to each other. Someone wrote this at some point in time to match up to a REST API over here, but as your developers continue to write REST APIs, it's going to get out of date. It's a problem. It also means that you don't have a single source of truth. If your REST APIs are not based on this schema at all, then you don't know which one to go to if you have a question about what do these APIs provide. Your GraphQL schema might have some stuff, but it might be different than, again, the underlying REST API. You could go to the other side of the spectrum and say, you know what, we're going to auto-generate all of our schemas. I'm not going to touch any of these things. And this is great. So if you have the ability to, if you have a really, really consistent REST API, maybe you're using a framework, maybe you're using Swagger / OpenAPI, I think they're the same thing now, you can actually reuse those same schemas to generate a GraphQL schema. At Coursera, we have our own schema definition language. We call it Courier, and we use that schema language as our source of truth. We use that to auto-generate our GraphQL schema, and that provides us the ability to support both REST and GraphQL clients. If your REST API over here is supporting clients over here, and you have a GraphQL thing that's based on the REST API, then they're always going to be in sync, and you can support both clients as necessary. Cons. These are big cons. One is that changing or modifying the types is actually really high friction. So you can't just change a number to a string. Now you have to go all the way back to the source. You have to go all the way. You got to work in Scala or your backend language, whatever it is. You have to go and change that thing, deploy some backend services. If you're a front-end developer like myself, that sounds like a lot of friction. And on top of that, your auto-generation layer, in this case, we have a custom schema definition language, or even if it's Swagger or any other API schema, you have to have the auto-generation layer understand how to translate that schema to GraphQL. So if GraphQL has a new operation, or if this API has some new thing, you're going to have to deal with that process as well. So there's still some stuff lost in translation between your base schema that you're auto-generating your schema from, your GraphQL schema from. The third option is, of course, a combination of both. You get all the strengths and none of the weaknesses. So the pros, one is, and that might not actually be true, but let's just go with it. So the first thing is, you don't have to manually translate all of your atomic REST resources. And what I mean is, at Coursera, we have 600 to 800 different REST resources, manually trying to create representations of that in GraphQL sounds like a really, really boring task. If we have the auto-generation layer that knows how to translate one REST resource to GraphQL, let's just run that 600 times. Let's let the computers do our hard work for us. But because we're combining both the auto-generated stuff with the manual stuff, we can also extend those types as needed, or we can compose different resources together, which ultimately your clients are just composing those REST resources themselves for their products. The cons, your source of truth now isn't your basic backend API, it's GraphQL. That's not the hugest con. That might be OK. But for some people, this might be a deal breaker. And so you have to think about this as you're trying to figure out how am I going to get to GraphQL from all of these REST things. Another question that you're going to have to ask yourself as you're translating your REST APIs over into GraphQL is how you're going to actually expose those APIs within GraphQL. And there's a few different options. I'm not going to go through the pros and cons of both, but I'm going to cover the two things that we kind of deliberated between, and well, I guess I am going through the pros and cons. Some of the benefits of both. So if you see here in this query, in the top, we see this pets v1 resource, and then a find by name filter that gets you a pet by a name. And then the other option, which is your more prototypical GraphQL example, which is find pet by name. And in the first case, this name spacing fields in GraphQL based on their REST resource is a lot more RESTful. It feels like you're going to have sections of namespaces, each corresponding to each API. And this is good. I mean, this is a very easy way for any developer that uses REST to be able to use GraphQL out of the box, because it looks just like the REST APIs that they were using. And on top of that, if you need to be able to filter by a particular type, or if you need some fields on this resource, it's very easy to find where they are. When you're looking through Graphical and you have all these types, it's very easy to find because it's all in the same section. They're all namespaced by the REST resource that they have. The other option is to do it around use cases. And this is kind of more GraphQL-like in that you describe maybe a page, or maybe you describe an exact, here are the things that I'm going to need for one exact use case, and list them out here. And in this case, we're going to find a pet by a name. This feels better, but for someone coming from REST, what we found is that if we went with this route, we would see a ton of pollution in this global namespace. Now there's 800 different things. If we have multiple resources that are named different courses, it could be a find course by name. We don't know which course is that, what that's actually going to mean. So there's benefits and drawbacks to both. Whether you go with the RESTful sort of namespacing route or the use case route, I'm sorry I don't have a silver bullet for you here. You're just going to have to figure it out and just stick with it. Don't do both. But doing both, it might help, but you just be cognizant that it's going to get messy. And just like REST, GraphQL is not going to fix that problem for you. It's still going to be messy. So just find a decision that you're comfortable with, some rules that determine how you deal with RESTful resources versus your use case resources, and just stick with it. So I'm going to cover a little bit about managing your API request volume. And this is going to be pretty relevant for those of us who are building GraphQL servers. And this is important because the way that GraphQL works, every field is going to get resolved, and every one of those fields might resolve against a REST API. And what that means is that you're going to get a ton of REST API requests, and you're definitely going to get throttled, speaking from personal experience. So here's a few top-level, really easy ways to safeguard your GraphQL server from getting destroyed. And these aren't really relevant to REST yet. These are just high-level things that you should be doing regardless. So this first one is query complexity. And what it does is that it takes your query and then does some hand-waving and says, hey, there's a few fields like this. And in this case, we see there's two fields, droid and ID, as well as 3 fields, pets, name, and age. And it's going to multiply those last 3 fields by the limit, and it's going to say 63 is your magic number. And this is great. Now you have a number to determine how many possible REST requests you might have. And based on how many times you traverse things and how many nested fields you go and how many limits you have, this could be up in the thousands. This query complexity, you can change the weight. If you have one API that's really, really slow and you want to say, OK, anybody that uses this one API, give them a huge query complexity. In any case, what this is intended to do is that at static analysis time, at compile time, determine, are we going to be able to serve this request efficiently? If not, throw it away. I don't even care. I don't even have to run this to know that it's going to take too long to return. So that's query complexity. The second is, OK, so this, all right, we're going to talk a little bit about this emoji. So this emoji is supposed to be the guy, it's supposed to be man gesturing no. And then I tried to find the skin type that matched my complexion. And that's what I got. It looks like a piece of poop, kind of just a ghost maybe. And this is, I don't know what happened because this looks great on my computer. In any case, another thing that you can check is maximum query depth. And this is because of the nature of GraphQL, because it's a graph, you can have cycles. And so if you're traversing like this, you're going from droid to pets to owner to pets to owner to pets to owner to pets to owner to pets, that can go forever. So you can just say, you know what? You probably don't need to go that many times. You can stop after 5 or so. So this is just a very easy check to see, you know what? This query is not going to, this isn't great. Let's throw this away. Here's the ghost emoji again, and this is what it's supposed to. It's this guy on the right, but doing the X. In any case, another option that you can use to really safeguard your system is using persisted queries. So even though you have this query complexity thing, even though you have this maximum query depth thing, you want to make sure that not anyone can arbitrarily hit your system, because GraphQL is going to, again, shoot a lot of requests out. And so what it'll do is it'll take this query on the left, which may or may not be really complex, and at compile time, you're going to verify it and say, yes, I put my stamp of approval on this. I'm going to give it an ID. This ID, in this case, is some query ID. And when you make this request to your GraphQL endpoint, instead of sending this big query document, you send just the ID. And that we can verify on our system to say, yes, we verified that this ID is created by our team and that we will actually serve this request. This is more of a security thing, but it's also a good way to make sure that your queries have passed all the verification steps in order to create that ID. And that means that random people can't just hook up to your graphical and spam your servers. Also very important. This is, I say you may want batch APIs. You're going to need batch APIs. Your REST APIs, if you look on the right side, you'll recognize like /API/people, and then maybe it returns you a list of friend IDs, and you're going to go ahead and iterate over all the friend IDs to grab individual friends, and you're going to make 4 different requests to different APIs. This is going to blow up real fast. So if you have an API like the bottom, if you can't see on the bottom, it says query parameter IDs equal, and it has a list, a comma-separated list of all the IDs. You get 1 request, but you get all the information back that you need. And this will save you a ton of pain and heartache over all the big fan out of requests that you're going to get in GraphQL. Don't get throttled, really, really important. Make sure that you whitelist your GraphQL server against your APIs, because, again, you're going to be generating a ton of requests here. You can send a header as a secret. This one says DJ Mashco. And this just makes sure, again, that you have a way to authenticate your GraphQL server. And then if you are implementing the GraphQL server yourself, you'll want to memoize a lot of your REST calls. So as you traverse through all of these resources, you're going to be retrieving all this stuff from different APIs. You're going to be using IDs a lot, and that's how you're going to be able to access things in REST. Turns out if you go from here, like say you go from droid to pets to owner to pets, and you go back over the same person or the same entity with the same ID, there's no need to make another request. You can memoize that and save yourself a ton of requests and just serve it from memory, because you know in the execution chain that you've already retrieved this information. If you use JavaScript, this is your data loader, if you've heard that before. And in other languages, there's different options for memoizing this. So wrapping it all up, we're going to pull all this together. You have a schema that you've generated or manually created or a combination of both from your REST APIs, as well as a server that's going to be a really good tenant, and it's going to be able to make a ton of these requests to your REST APIs. And you're going to have to ask then some GraphQL-related questions. So the first question here is, who creates the graph? So we have individual REST resources that we've pulled into GraphQL, but we've done nothing to actually link them and to make them a graph. And that's an important question to have because, one, that's kind of the benefit of GraphQL. But it's also a question that you haven't had to deal with in REST. In REST, you probably know that this is a list of friends, so you're going to go make this API call with this ID. But for the first time, we're actually ensuring in the type system and in the GraphQL API that this actually is going to return to you a friend. And so those relationships are what create your graph. And there's a decision there, which is, should you put this in your REST layer? Like, do your REST APIs know that this is going to be a friend ID or a friend relation? Or does this only go into the GraphQL layer? It's not a huge decision, but it's important to know that you're going to need to store some information about the graph because this does not exist and generally does not exist in the REST world. Another thing that's important is that we've talked a lot about all the little decisions we had to make around throttling, around how we deal with persisting queries, how we deal with constructing the REST calls and memoizing the calls. And you shouldn't have to keep rebuilding that every time you're building a new resolver in your GraphQL server. You shouldn't have to keep dealing with authentication and authorization and that sort of stuff. In fact, if you use things like OpenAPI or Swagger, you might be able to combine all of that and encapsulate all of that into one place. And using a library like GraphQL Binding, you can actually say, you know what, I figured out all the problems. I figured out how to access my REST APIs if they look like this. I figured out all the authentication. I'm going to package all that up into a little module. So if we look on the left here, you would give this system, for example, your OpenAPI schema, which is a REST schema, and it's going to auto-generate your GraphQL stuff for you. Like I mentioned, it's going to auto-generate that schema, and you can see what those eventually resolve to. Those resolve to get pet / some finder, and it gives you a instance of your API that now you can use to ping, and if you use your GraphQL server, you can use this, and it's going to handle all of the work around translating it to REST. You need to only solve that once, and then you can reuse it everywhere. That's really, really nice. Beyond that, you're also going to want to extend your graph. Ultimately, there's a lot of third-party or external APIs that you don't control, that maybe you don't have inside of your graph, or maybe you don't own the service. Luckily for us, using directives, using the links that were mentioned earlier, you can use a link called Apollo Link REST, which was written by Frederick, who's sitting on the couch over there. And this allows you to express very, very RESTful things inside of your GraphQL schema. But what's nice about this is the dream, which is you can access all of your data through GraphQL, and you're not going to need to know anything else. So as an overview, I covered how you're going to actually figure out if GraphQL is the right thing for you. Second, covering how you're going to capture and catalog all your REST APIs. Third, being a good tenant, making sure that you're using REST APIs well, because it's definitely going to be a problem, as well as how you're going to end up using and building your own GraphQL layer. Thank you. Yeah, time for questions. Yeah, so to repeat the question, Yordis was asking about persisted queries and how to deal with the management of and whitelisting the servers and stuff like that. Those are all options to deal with making sure that you're writing queries that will get through your systems. Our GraphQL servers sit behind in our VPC, or I'm just saying words, I don't know what they mean. Something such that we know that it's internal. So it knows that it's an internal client, and so we don't really need to deal with those things. But I mention it generally because some people have GraphQL servers external from their REST servers. Yeah.
Awesome. I think one question.
Yeah.
Last question.
Yeah, so the question is, how do you end up annotating query complexity for different resolvers and fields? The way that Sangria does it is that it allows you to determine, based on the actual type that you're generating, what the weight of that query is. And so again, if you have an API that you know is very slow, you give it a large query complexity score. But again, this is all hand-wavy. The numbers don't mean anything unless you make them mean something.
Does that mean resolver, you say this is a 5 versus this is a 10?
Yeah, so generally their baseline is okay, it's 1 for every field, and then multiply it by a limit whenever you see a limit. And then if you have a custom one, add 25, maybe multiply it by pi. It's really up to you to figure what that looks like. Yeah. All right, thank you.
Do you want to ask a truly last question?
Oh.
I was curious, the security, the DJ thing.
The question was, should your secret be bundled into the system? That's just generally a security thing, just to make sure that you're not throttling your servers. It has nothing to do with GraphQL. Oh, this is in the GraphQL server layer, not the client layer. So in the server, it would be making the REST request, and that needs the authentication, not your client. Your client's still making GraphQL queries. You don't deal with that part. Yeah. All right, thank you.
Awesome. Thank you, John.